Rocketeer. After all the bombs are away, the ports and libs must fight their way home again. That's not easy because many of them are cripples now. And now is when fresh fighter groups speed into the battle to help their big friends get back to Britain. Across the sky that mean fresh fighter strike. Brother, the battered bombers are plenty glad to see it. You see the whole story in these contrails. The broad massed trails are where the bombers turn for home. And there are the single streaking trails that show how the thunderbolts weave above the homing bombers as top cover. Look at that port's tail, a 20mm chewed it off. Bombers are bound to get it. There goes one of the big boys spinning down. Some of the fighters get it too. There's the single shoot of a Thunderbolt pilot floating down. Many of the men shot down over Germany are still alive, prisoners of war. Black smudges of the flak that come up from the anti-aircraft guns below. Battle stays hot as ever through flak and fighters as the ports move on and on to the coast. Sometimes the battle goes on halfway across the channel. Welcome is the sight of the coast of England. But even then, the battle is not ended, because crippled planes must still be landed, and often that is not easy. The battle-damaged fighters limp home to land ahead of their group. Watch this landing. His right tire is shot away. Hold it. And at last, he's down. And now a group of Lightnings land. The 56th group comes home. Flight after flight will peel off. A new flight moves into peel-off position as each proceeding flight goes into the approach. Gas is low. The first are down in close order. They must clear the end of the field as fast as possible. Each plane taxis to its own hard standing, widely dispersed around the field. That took the pilots to their planes now take them back to the interrogation. A pretty happy bunch. They got 4 Huns and lost none of their own planes today. Now, this is the Thunderbolt group that swore back last April that they would knock down 100 Huns by Armistice Day, and they made it, with 2 to spare. The F-2 officer, the pilots call him the spy, conducts the interrogation. It's a lot different from the last time they were together, when they were tense and expectant at briefing. The spy will ask, well, how about the rendezvous? And Gabby, as squadron leader, will reply, we hit it on the nose, 1558 at Zoot Camp. And then the spy will say, okay, and now for the claims. How many Huns did you get today? Well, I blasted one parked over that island. He took plenty of lead, but he went down. And then another one. I parked him on a cloud. Nice shooting, brother. And how about our big friends? Did anybody see any bombers go down? Yeah, I saw one. 6 guys bailed out. Any more claims? Yeah, I got one of those rocket carriers. He tried to get away, but I nailed him. And so it goes. Another ramrod comes to an end. It's been a good one. Only 4 bombers were lost today, thanks to the fight. Bottoms up, the hunting was good.
Absolute protection of classified documents is a necessity for both government and industry. Recognizing this requirement, Harry C. Miller, president of Sargent and Greenleaf, made extensive research into the problem. By developing the first revolutionary departure from accepted principles in 75 years, a new idea was born and security was created. Creating security necessarily involves the ingenious thinking and creative abilities of an entire organization. The basic thinking and ideas of Mr. Miller were turned over to Sargent and Greenleaf's product committee. Here, every facet of top-level management, engineering, sales, and advertising are brought together to analyze, discuss, and develop the original conception, so it can be culminated in the end product with the best possible means of accurate and highly skilled manufacturing procedures. Coordination of effort is mandatory. The sales department must consider and bring out the aspects of marketing as well as the distribution problems. Advertising formulates plans to present the product to the markets by the various media available in coordination with the sales program. Manufacturing and production personnel bring out the many problems attendant to producing a high-precision and accurate device, and report on the various procedures and methods to be employed in the manufacture operation. Design, engineering, and tooling are the basis for the entire procedure, starting with part drawings, specifications, as well as operations or method sheets. Tolerance studies are made to ensure compatibility of parts and ease of assembly, utilizing the latest production techniques. The tooling program begins with the fabrication of molds, the necessary jigs and fixtures. Here is shown the latest technique in mold making by use of electronic die sinking equipment. A brass electrode is made, conforming to the configuration of the cavity of the mold to be made. Utilizing highly controlled voltage and under a bath of oil, the electrode is duplicated in reverse in the mold steel. Upon completion of the mold and other tooling simultaneously made, production of parts is begun. The die casting operation in Sargent and Greenleaf's modern up-to-date foundry utilizes equipment with extremely high locking pressure to ensure good quality, dense castings closely controlled. The zinc alloy is injected under extreme pressure. The entire procedure is repeated time and time again, resulting in continuous production of quality precision parts. The die casting process ensures production of almost identical parts with the high degree of accuracy necessary for production line techniques. After the castings have been removed from the gate, they are die trimmed to remove the excess material and prepare the part for any secondary machinery operations. Die casting begins with ingot material, which is brought to a fluid state and, as shown, injected into a metal mold. When the parts are ejected from the mold, they are on a gate. The conical section is where the material is injected. The molten alloy flows into the runners and to the cavity, thereby forming the parts. After the parts are broken off, the gates and runners are remelted in the properly alloyed amounts with virgin metal for future use. Because the metal mold is used, great detail can be obtained, including the casting of small holes and odd shapes, so necessary for the function of this high-precision locking mechanism. The secondary operations on the individual parts are performed, such as drilling holes, which are not practical to produce in the basic die casting. Multiple spindle operations perform drilling and tapping operations in sequence to keep costs at a minimum, while high quality control standards are maintained. Other parts made from rod material are fabricated in the screw machine department, which also provides high production facilities for minimum cost. The various operations are performed automatically under close supervision and inspection. Continual quality control is maintained by the use of the latest inspection techniques, which permit control of critical dimensions and assure the quality of the product. A contour projector is used for rapid, accurate inspection of the can. Degreasing and cleaning of all parts is made prior to application of organic and electrochemical finishing. A plated or painted finish gives the required protection against corrosion, so necessary for trouble-free operation over a long period. Upon completion of secondary operations, the dial and spindle assembly are pressed together by hydraulic press. Control of the concentricity between dial and spindle is extremely important. Positive control in the cutting of the spindle with respect to the proper number is maintained to ensure the correlation of the dial numbers with the inner working mechanism of the lock. After the spindles have been pressed in and cut, the dials are painted with the background color depending upon the customer's requirements. The paint is baked under high degree of heat, utilizing electric units in a continuous oven. The paint hardness must be able to withstand the usage to which the lock will be subjected in the field. After the dials have been cooled, the numbers are filled in with a contrasting color by spraying and wiping. Here is illustrated the dial and the operations it goes through in the painting sequence. The tube, which serves to orient the dialing indices with the mechanism, is made as an aluminum extrusion, which is cut to the required length, threaded for adjustment and fastening. The 4 splines or grooves permits application and adjustment in the field. The 4 positions of application, vertical up, horizontal right hand, vertical down, and horizontal left hand, are easily obtained by rotating 90 degrees. The lever assembly, made of brass for protection against corrosion, has stampings for the lever body and screw machine parts for the bushing and fence. Here, the lever bodies are being stamped out. The parts are then assembled and brazed. The lever assembly connects the bolt of the lock to the working mechanism so that when the wheels are aligned after the proper combination has been dialed, the lever fence enters the gates of the wheels and permits the bolt to be retracted. The heart of a combination lock is the wheel pack assembly. The various parts are assembled into position and staked under high-quality control standards to ensure long life and continued functionability. Highly skilled personnel with years of experience are utilized for this all-important assembly operation. Changing wheel must be precisely assembled, or it must be so constructed as to permit changing of combination countless times without failure. Here are shown the various components which comprise a single wheel assembly and their position in the assembly. The various parts are the cases, studs, center, lever, counterweight, and the locking cam. When all of the parts have been fabricated and quality control has approved the parts for assembly, various sub-assemblies are made. The final assembly is made by application of the various components into their proper position in the lock case. This stack-up of parts is continued until the three-wheel assembly is made. The wheel pack assembly is held in position by a Spiralike's top washer, which ensures full bearing around the diameter of the wheel post. The bolt is inserted and the lock lever screwed into place by means of the bolt screw. The spring is hooked to the lever so that there is tension on the lever at all times. Absolute control of the amount of tension is a requirement, not only for good function, but also to ensure acceptance under the rigid requirements of the Underwriters Laboratories Group 1 procedure. The drive cam is then inserted into the wheel post and the dial put into position, assuring that there is sufficient end play before insertion of the spline key. The inner spindle mechanism, which controls the slide of the MP lock, is inserted, and after that, the cover is applied. The assembler sets a working combination of 50, 25, 50 to the lock by dialing the three numbers using the changing index and locking the wheels into position. The lock is tried on the working combination to ensure functionability. Each lock is sent on to the inspection department to ensure the lock meets the high acceptance standards. The MP combination lock shown here in an exploded view is the finest locking device available today. It is the culmination of years of research and development into the security requirements of our country. The project is now completed, and the basic development is then locked up behind its own creation, the Sargent & Greenleaf manipulation-proof combination lock. Other fine products by Sargent & Greenleaf are the high security combination padlock, institutional builders hardware including panic exit devices, door holders, as well as accessories to meet the requirements and specifications of today's changing world.
I knew you'd come knocking on my door some morning. I knew you'd come knocking on my door about dawning. I knew you'd come knocking on my door. Knock, knock, knocking like you never did before, but it ain't gonna do you no good this morning. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in. You stayed away too long. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in, 'cause you done me wrong. I left my door wide open, babe, and hoped you'd come around. Now I've got somebody else, so get on back to town. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in. You stayed away too long. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in, 'cause you stayed away too long. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in, 'cause you done me wrong. I left my door wide open, babe, and hoped you'd come around. Now I've got somebody else, so get on back to town. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in. You stayed away too long.
Brother Jeannie, brother dear, what are they saying and what do I hear? Into the doggone dirty shame, somebody's scandalizing my name. They put me on the grease and give me no peace. Still they got me going around picking up daisies. Talk about me and talk about me till the cows come home and the bulls go crazy. Brother Jeannie, brother dear, what are they saying and what do I hear? Into the doggone dirty shame, somebody's scandalizing my name.
Spread your playing taps yourself, try to be a sport. Here comes dragging it back to me, an hour late and an hour short. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in. Keep a knocking, but you can't come in. You stayed away too long. You left me sad and lonely. You left me by my only. You stayed away too long.
Visual reference to the ground is uncertain or impossible because of clouds or darkness of night, radio aids to aerial navigation enable the pilot or navigator to initiate instrument flight. In addition to his maps, charts, and the instruments of his airplane, the pilot can readily follow his flight plan with the aid of directions, signals, and information transmitted to him by radio from many points along his route. Air navigation radio aids, published by the Civil Aeronautics Administration, and radio facility charts by the Air Corps, supply detailed information which facilitates full use of the various radio aids along the airways. After referring to the index on the back page of the handbook, the pilot then turns to the particular chart covering the section of airways over which he plans to fly. He finds many symbols along his proposed route, each serving as a definite marker, and each involving the use of some portion of his radio equipment. Radio range stations, operated by the Civil Aeronautics Administration, are located at principal cities and at certain intersections of airways. Each radio range station serves as a directional aid to pilots. At most radio range stations, the transmitting antenna consists of 5 vertical radiators, 4 of which are located at the corners of a square, and the 5th at the center. Any 2 diagonally opposite radiators project a radio field, which is maximum along the axis of the 2 towers and minimum in the 2 directions perpendicular to the axis. If the letter A is transmitted over a pair of these radiators, the greatest signal strength is projected in line with the radiators. In code, A is dot dash. These dot dash signals are strongest at the point of transmission and get fainter as they get farther from the transmitter. When a second pair of radiators is placed at 90 degrees to the first pair, it projects a radio field of similar shape and at right angles to the first. The letter N is transmitted over this pair of radiators at the same radio frequency. In code, N is dash dot, just the opposite of the A signal. Thus, 2 distinct radio fields are established, intersecting at the point of broadcast.
The signals transmitted by each pair of radiators are audible on each side of the axis of their greatest strength, getting fainter as they spread out. Let us examine 1/4 of the field. The two signals overlap perfectly, making a continuous tone or on-course signal at the line of intersection. This line of intersection, always giving the on-course signal, determines the location of the radio beam. When these signals are properly synchronized in transmission, they will interlock or mesh like the teeth of a gear. When both have the same tone and volume, neither can be distinguished, but instead a single monotone or on-course signal is produced. The continuous monotone established by the overlapping of the two signals takes the form of a long, narrow beam. It is bordered on one side by the so-called N zone, with the letter N being audible, and bordered on the other side by the A zone, with the letter A being heard. A radio beam, therefore, is a long, narrow directional beam with approximately 3 degrees spread, located between the N and A zones. This map shows how the United States is covered by these ranges. For a short distance on each side of the radio beam, there is a space known as the bi-signal zone, in which the monotone is heard, but with the A or N signal distinguishable above that background. As a pilot departs from a beam, one letter becomes more and more distinct until the background monotone disappears. At the very edge of the radio beam on each side is a narrow border which is known as the twilight band. In this very narrow band, either the A signal or the N signal can be barely distinguished against the monotone background. If all signal fields are of equal transmitting strength, the 4 legs of the beam emanating from a radio range station will be at 90 degrees. Very often this is not desirable, since the beams would not correspond to the direction of the airwaves. The direction of the beams can be adjusted by increasing the signal strength of one field, which will impose itself upon the 2 adjacent fields and will result in a change in the direction of beams as desired. Directly above the antennas, or towers of the radio range station, there is a dead space where signals are almost inaudible. This is known as the cone of silence. This is a limited area shaped like an inverted cone, in which all signals fade. As an airplane approaches, volume of the signals increases rapidly because of the proximity to the point of broadcast. As it enters the cone of silence, they fade abruptly. When it leaves, the signals surge back with great volume, then slowly diminish as the distance of the airplane from the station increases. Occasionally, while flying, a pilot may experience a momentary fading of the signals or a false cone of silence. This can be distinguished from the true cone of silence because of the absence of the surge of volume at the edges of the cone. The A and N